Dear students, today we are going to learn initial and final value theorem in Laplace transform. Let us see the statement of initial value theorem and final value theorem followed by the utility of this theorem. Let us see the statement of initial value theorem. If Laplace transform of f of t equal to f of s, then limit t tends to 0, f of t equal to limit s tends to infinity s into f of s. The utility of this theorem lies in not having to take the inverse of f of s in order to find out the initial condition in the time domain, and this is particularly useful in circuits and systems. Now let us see the statement of final value theorem. If Laplace transform of f of t equal to f of s, then limit t tends to infinity f of t equal to limit s tends to 0 s into f of s. Again, the utility of this theorem lies in not having to take the inverse of f of s in order to find out the final value of f of t in the time domain, and this is also particularly useful in circuits and systems. Now let us see example problem. Verify initial and final value theorems for the function f of t equal to 1 plus e power minus t into sin t plus cos t. And before verifying initial and final value theorem, we should find out f of s, capital F of s. By taking Laplace transform for the given function f of t, we can obtain f of s. L of f of t equal to Laplace transform of 1. We know that Laplace transform of constant is k by s, that is 1 by s here, plus Laplace transform of e power minus t into sin t plus Laplace transform of e power minus t into cos t. Now we have to apply first shifting theorem. So Laplace transform of e power minus t into sin t can be written as 1 by s plus 1 whole square plus 1 plus Laplace transform of e power minus t into cos t can be written as s plus 1 by s plus 1 whole square plus 1. Now we have to simplify it. 1 by s plus s plus 2 by s plus 1 whole square plus 1, and this is f of s. Now we can go for initial and final value theorem statement. Initial value theorem states that limit t tends to 0 f of t equal to limit s tends to infinity s into f of s. First we have to find out left hand side of the theorem. Limit t tends to 0 f of t. Now we have to replace t by 0 in f of t. 1 plus e power minus t into sin t plus cos t. You have to replace t by 0. 1 plus e power 0 into sin 0 plus cos 0. We know that sin 0 is 0, cos 0 is 1. So 1 plus 1 equal to 2. Left hand side of the theorem is 2. Now we can go for the right hand side. Right hand side is nothing but limit s tends to infinity s into f of s. We found out f of s already. You have to multiply s with f of s. So you have to multiply s with the first term. S get cancelled. Now we have 1. You have to multiply s into s plus 2 divided by s plus 1 whole square plus 1. Now we cannot apply the limit value directly because we will have a indeterminate form. So that we have to make it finite limit by taking out the higher powers of s, or otherwise we can use it L'Hopital rule to obtain finite limit value. So here 1 plus s square into 1 plus 2 by s. In denominator we have a s square into 1 plus 2 by s plus 2 by s square. S square get cancelled. Now we have a 1 plus 2 by s by 1 plus 2 by s plus 2 by s square. Now we can apply limit value. Now replace s by infinity. Any value by infinity is 0. So we can get 0 here. That is 1 plus 0 divided by 1 plus 0 plus 0. We have 1 plus 1 equal to 2. and this is the right hand side of the theorem. Already we found out left hand side of the theorem, that is 2. Left hand side and right hand side of the initial value theorem is 2. So we can say initial value theorem verified. Now we can go for final value theorem statement. Limit t tends to infinity into f of t equal to limit s tends to 0 s into f of s. Now we can easily memorize it, the final value theorem. From initial value theorem, in left hand side t tends to 0, here t tends to infinity. In right hand side initial value theorem, s tends to infinity, but here s tends to 0. Left hand side of the final value theorem is limit t tends to infinity into f of t. Now replace t by infinity, 1 plus e power minus infinity. We know that e power minus infinity is 0. So that 1 plus 0 into anything 0. So we have a 1 in left hand side of final value theorem. Now we can go for right hand side of final value theorem, that is limit s tends to 0 s into f of s. You have to multiply s with f of s. Now we have limit s tends to 0, 1 plus s into s plus 2 divided by s plus 1 whole square plus 1. Now replace s by 0, 1 plus 0 by 1. 0 by nothing? 0. So we have a 1 plus 0 equal to 1. So left hand side and right hand side of the final value theorem is 1. Hence initial and final value theorem are verified. Thank you for watching this video.